Welcome to aminacademy.com. In engineering mechanics, let us discuss about combined motion of rotation and translation. Look at this figure. A car wheel rotate with its own axis as well as the car translate in linear motion. This, if you consider a motion of a wheel as a rotation as well as translation of the car is considered as a combined motion of rotation and translation. That means while wheel rotate with its own axis, at same time the wheel translate from straight line or curved path. This motion of the wheel is said to be combined motion of rotation and translation. Here, look at this figure. Consider a link AB, a rigid link AB, which moves from its initial position AB to its final position B1, A1, B1. That is, this link AB moves like final position A1, B1. It will be interesting to know that the link neither has wholly a motion of translation nor wholly a rotational, but a combination of two. Here, it is neither wholly a translation not wholly a rotation. It is a combined motion of translation and rotation. But the point P moves faster. The point B moves faster than the point A, as shown in the figure. If we split up the motion of a link AB, we shall find the link has first motion of translation AB. Here, suppose we consider this AB is motion of translation like A1 B dash, then motion of rotation about A1. That means first the link AB moves translation like A1 B dash. From that position, A1 as a center and B dash move as B1 like rotation. Here first AB translated here and with center A1, B dash rotate to position B1. Then final position of this one is A1 B1. Such a motion AB to A1 B1 is an excellent example of combination of motion of rotation and translation. Here first we can consider this way also. AB is first, B is rotated with respect to the point A and AB dash translated to A1 B1 like also possible. Look at this one more example. Look at this link. L link is connected with hinge of P1 and P2. That means what? This the frame, that is A P1 and B P2 can oscillate like a car wiper. It can oscillate. While it oscillate, here it is here this at point A and point P with position of that one. This L links move as a rotation like, because of movement of the frame here, like wipers oscillating like, due to that this also, this L link also having a rotation and translation. This the point about the point P, this point P is called a instantaneous center. Now further explanation how to find the instantaneous center of here we will find the instantaneous center of a moving body. Here the consider motion of a link AB from AB to A1 B1. Here we have to combine the motion of rotation and motion of translation. Here this motion translate A B1 translate A1 B1 as well as it's rotated. This combined motion of translation and rotation may be assumed to be motion of pure rotation about some center. Here these two, that is translation motion as well as rotational motion, is combined together and considered as a purely rotational motion with respect to some point, that is some center. This is called a O is a instantaneous center. That means the definition of instantaneous center is the combined motion of translation and rotation has considered as purely rotation with respect to some point. Here that point P, this point is called this here point O. This point O is instantaneous center of that motion. Here O is the instantaneous center. Now how to find a instantaneous center graphically? Look here. First draw a diagram of with some scale of that position of AB, and after translation and rotation the position as A dash B dash. Now join A dash and B dash with a straight line. Now find a perpendicular bisector of a line B dash, that is here RS, and perpendicular bisector of A dash A1 as perpendicular bisector is PQ. Now join extend RS and PS, let it meet some point O. That point O is instantaneous center of two motions. Now here this is VB, linear velocity of the point B. This is VA. Now consider some calculation here. Linear velocity of point A. Point A equal VA equal omega into OA, where omega is angular velocity of AB. Angular velocity of AB and like, or you can write this one as omega equal VA by OA. Similarly, omega angular velocity of AB is VB by OB. Now, from these two expression we can write VB by OB equal VB by VA. VB by VA equal OB by OA. The direction of VA and VB will be right angles to OA and OB respectively as shown in figure. Here from this relation we can from the graphically we can measure OB and OA. From that we can find the relation of linear velocity of VB and VA. Now we have done. Please subscribe our YouTube channel.